Good morning, my dear student. Today I am going to start young modulus of elasticity F by A delta L into L. Similarly, yesterday I discussed about this one question, and then bulk modulus of elasticity is equal to minus P V by delta V. This is question number 2. In this equation, we can find out the value. That one value is equal to how can you find the value? A steel wire of length 4 meter. Suppose we have given the equation. If a wire of length 4 meter is stretched 4 meter and the radius 2.5 millimeter is subjected to a force 5 kg weight. Find the elongation of the wire. Find elongation in the wire. Given young modulus is equal to 2.4. Given elongation 2.4 into 10 to the power 12. 2.4 into 10 to the power 12 dyne per centimeter square. So how can you solve this one question? We can solve this one question by using the formula y is equal to F into L A delta L. First of all, we can calculate area. Given area is equal to pi r square. So r is given 2.5 millimeter. 2.5 millimeter. Answer: r is equal to 2.5 millimeter is equal to 0.25 centimeter. L is equal to 4 meter means 400 centimeter. Force F is equal to 5 kg weight. 5,000 gram weight. This gram weight is converted into 5,000 multiplied by 989. Is it? Therefore, we apply the formula y is equal to F into L by A into delta L. F is equal to 5,000 into 980 multiplied by 400 by 5 into 0.25 whole square into delta L. This delta we have to find out. Therefore, we write the value of y. Y is given 2.4 into 10 to the power 12. 2.4 into 10 to the power 12. Therefore, delta L is equal to 5,000 into 980 into 400 divided by 5 means 3.14 into 0.25 whole square into 2.4 into 10 to the power minus 10 to the power 12, and its value comes out as, by solving, we get 0.0041 centimeter. 0.0041 centimeter. It is your answer. That is the elongation in the wire. Is it clear? How can we use the formula? In the same way, we can calculate the bulk modulus of elasticity. In the way, now second question is, in this way we can use this one formula and solve the numerical of the elasticity. Now second one, what is the pressure on a sphere? What is the pressure on the sphere? What is the pressure on the sphere? Sphere on the sphere is increased by 80 centimeter. Is increased by 80 centimeter. 80 atm atmospheric pressure increased by 80 atmosphere, then its volume decreases by 0.01%. Then its volume decreases by 0.01%. Find the bulk modulus of the material. Find bulk modulus. Find bulk modulus of material of sphere. Therefore, P is equal to 80 atmosphere. Then its value comes out as given answer. P is equal to 80 atmosphere is equal to 80 into 1.013 into 10 to the power 5 delta V by V is equal to 0.01 by 100. 0.01 by 100. Then you have to calculate the bulk modulus of elasticity. Bulk modulus of elasticity. Then V is equal to PV by delta V. We ignore the negative sign and we get P is equal to 80 into 1.013 into 10 to the power 5 V 0.01. This 100 goes to numerator side and its value comes out as 8.1 into 10 to the power 10. 8.1 into 10 to the power 10 Newton per meter square. That is the answer. Is it clear? Now, you are, which one is more elastic? Rubber or elastic? Which one is more elastic? Rubber or steel? How can you explain? This one question is asked in the 2 marks. And that's also very, very important for your final examination. Which one is more elastic and why? Is it or not? Which is more elastic, rubber or steel? Explain your answer. How can you explain? Which is more elastic? which is more elastic, rubber or steel, rubber or steel. Explain. Then how can you explain? Suppose we have given the two rod of the one is made of the rubber, another one is made of steel. So that we can write young modulus of the steel. Let delta R L R answer having the same length, same force is subjected to it. Delta LR, elongation in rubber, Therefore, young modulus of rubber is equal to FL by delta LR into A. Area of cross section of the same size, but we apply the same force F. Length of the rubber and steel wire both are same. Equation number 1. Now let delta LS is equal to elongation in steel. Therefore, YS is equal to FL by delta LS into A. Equation number 2. Now divide this one equation. We get YS by YR is equal to dividing 2 by 1. We get YS by YR is equal to delta LR by delta LS. Which is more elastic? Which one is more? This one ratio. Delta LR more than delta LS. So that this ratio is greater than 1. Therefore, young modulus of steel is more than young modulus of rubber. Hence, we can say, therefore, steel is more elastic than rubber. Therefore, steel is more elastic than rubber. In the same way, we can also discuss the stress and strain. Stress and strain relationship in a wire. All of you understand? Delta LR is the elongation in the rubber. YR, young modulus of rubber, F into L by delta LR into A. Where for steel wire, delta LS elongation in the steel wire, YS is equal to F into L by delta LS into A. Dividing 2 by 1, we get rubber is more elongating than steel wire. That's why this one ratio is greater than 1. Since delta LR is more than delta LS, therefore young modulus of steel is more than young modulus of rubber. Therefore, steel is more elastic than rubber. Now, our second one question is state that one question is related with the Hooke's law. Draw a stress versus strain curve. Draw stress strain curve and define the following. In this four term are, one is the One is the first one is the elastic range. Second one, elastic range, permanent set. Third one is the yield point. Fourth one is the breaking stress. First of all, we draw this one. Is it? And then after that, elastic region, this one point O, A, B, C, D, this one is the plastic region. Plastic region, this one is the E point, that is the gapping point. The wire will be permanently deformed, that is called breaking point, breaking stress. This one point is the permanent set. Permanent set. Let a wire is suspended from the rigid support. Let a wire is suspended from a rigid support and a load is applied. When we apply the load, the stress also increases and strain also increases. So up to the point A, if we unload the wire, up to the point A, if we unload the wire follows the same path AO, and that region, when the deforming force is applied, body regain their original shape and size. And that region of the graph is known as elastic region. Is it clear? Second point. First point is clear, elastic region. Second point, when apply the load, strain will be increases by very large quantity. For a very small load wire, for a very when again more force is applied, more strain will be developed. If you unload the wire, then it will be follow directly B to A dash point. But they have to follow BAO. Instead of BAO path, the wire follows the path BA dash, and that one BA dash is a permanent deformation in the wire. This permanent deformation in the wire is called permanent set. So first one point is elastic region. When load increases, stress increases, strain also increases. Stress increases, strain also increases up to the point A. If we unload the wire up to the point A, then wire follow AO path, and that one region of the graph is known as elastic region. Again, second one point is permanent set. Permanent set. If we apply stress, load, if we apply load, more and more load, a very large strain is produced in the wire. Very large strain is produced in the wire. If we unload the wire at point B, the wire should be follow the path BAO, but they do not follow the path BAO. It follows the path BA dash, and that one OA dash, that one region of the graph is the permanent set. Again, a little stress is applied, little load is applied. The wire begins to flow, very large strain will be produced, very large strain will be produced. At a point, at a certain point, the wire begins to flow like that a viscous fluid, and that one point is known as yield point. Yield point at C. Up to the, then again I explain you, when load increases beyond the point C, very large strain is produced in the wire. Up to the point C, the wire begins to flow like a viscous fluid, and such a point at which the wire, beyond the point C, there is a curved line, there is a zigzag line, and that one thinning of the wire start, a neck and breast or constriction are developed at few weaker portion of the wire, and finally the wire break, and that one point is known as breaking stress. Before that one, the point C on which the wire yields to apply stress and begins to flow down is called yield point. That one point is known as yield point at point C. Then again load is applied, again stress is applied. Fourth point, again load is applied, load or stress is applied. Then the wire, so the waist and necks and waist or constriction are developed, and then finally the wire will be break down at this point D or E point, and such a point is known as breaking stress. The stress corresponding to the breaking point, is known as breaking stress. Is it or not? Breaking stress. At point E. The stress corresponding to the breaking point is known as breaking stress. Again I will explain you. Let a wire is suspended from the rigid support and force is applied, load is applied. When the load is applied, strain is also produced, or stress is applied, strain is also produced up to the point A. If you unload the wire at point A, the wire follow the path AO. Means stress increases, strain also increases. If the stress decreases, strain also decreases. Means they obey the Hooke's law, and that region of the graph is known as elastic region. Now stress is applied. Second point, stress is applied. Very large strain will be produced. Then the stress, if we unload the wire at point B, the wire should follow the path BAO, but the wire follow BA dash. That means the wire will get permanently deformed. Such a permanent deformation in the wire is known as permanent set, and represented by OA dash. Now again stress is applied, very large strain will be produced. At a point up to the point C, the wire begins to flow like a viscous fluid, and that point is known as yield point. That point C is known as yield point. Again That one region of the graph is known as plastic region up to the point D. Then very less stress is applied the while in break. The stress corresponding to the breaking point is known as breaking stress. The stress corresponding to the breaking point is known as breaking stress or tensile stress of the wire. Is it clear? These are the 4 points comes in the exam. So all of you learn about that one from the book. In this way, your elasticity chapter complete. Next day, we will discuss about the viscosity. Thank you and have a good day.